We have randomly selected statistics students participate in an experiment to test their ability to determine when 1 minute or 60 seconds has passed. 40 students yield a sample mean of 56.9 seconds. Assume that the population standard deviation, we know it's the population standard deviation because it's a Greek letter. So if it's an English letter, it's a sample statistic. If it's Greek, it is a population parameter. Is 9.5 seconds. Use 0.05 significance level to test the claim that the population mean is equal to 60 seconds. Based on the results, does there appear to be an overall perception of 1 minute that is relatively close to an actual minute? Okay, so let's look. This is our list out of the lecture notes. So first we want to list out the known information and find the necessary formulas. So here's all my information. Now I know the population standard deviation, right? So this means I'm doing a z-test. So remember, you can download all the formulas here under assignments, and then test resources. There's a formula sheet, and I pulled the formula we need already, and then I've listed the information from the problem. Okay, so I'm going to start by doing my null, and now I've got all this. Now my null and alternative hypothesis is, well, what do I want to test? Well, I want to test that it's not equal to 60 and that it is equal to 60. Remember, the null is always equal to 60. You can see that's all three choices. And in our case, we just want not equal to, so it's going to be a two-tailed, so this middle one right here. If we would have said we wanted it was greater or less than, that would be one of the one-tails. Now, our next thing we want to do is we want to find the test statistics, so I'm going to do that. I'm going to plug in my known information here. So what do we know? Well, we know that x bar is 56.9. Sigma, what we're testing, is 60. That's what we're testing here. This is what we know, 9.5. That's what we were given. And we had 40 down here. Okay. So now I have to plug this into my calculator. So I'm going, hopefully get this to work. There we go. So 56.9 minus 60, that's my top, divided by, and now this is pretty easy if you wanted to carry it, but I always like to not round or write anything down because I'm less likely to make a mistake that way. So you can see there's the bottom. I'm using parentheses to make sure I do the square root, then I divide into the top. So there is my test statistics. So negative 2.06. Let's go back and see how many decimal places. I think they wanted 2, right? Yep. So negative 2.06. Well, it's going to let me write. Okay. Now, to decide on my final conclusion, I next need to, so I've got my test statistic. I need to find my critical value. So this is where we need to make sure we draw the picture. So I have the picture written here, and I need to find out what these values are, what's going to make my green rejection areas. So my significance level was 0.05. I have two tails. That means how much is in each? Well, divide 0.05 by 2, 0.025. I then looked this up on the Z table, which I forgot to open. So we look in the body of the table, and we're looking for 0.025, so that's right here. And we can trace that back to 1.96 and negative 1.96. When I come over here, this value here is negative 1.96. This is positive 1.96. And so these are critical values. The idea is if our test statistic is smaller than this or larger than this, they're going to fall in the rejection area, and we're going to be able to say it's not 60. So I come back here and I look, well, what was my test statistic? Well, negative 2. That is going to fall in this green area over here on this side. So that means I get to reject the null because it's in the green area. I reject it. This is the reason we draw the picture, because it's really easy then to see that, okay, my decision is I want to reject the null. This means there is sufficient evidence to warrant the rejection of the claim that it's equal to 60. So we're saying it's not 60. So we knocked down our 60. We're saying it's not 60. Does there be an overall perception that 1 minute is relatively close to an actual minute? No, because the overall mean is not relative because there's sufficient evidence to warrant the rejection of the claim. So that's what we're going to, and so that was our thing. So as you do this, you can see my steps here. Let me go back to my list of steps. We wrote out all our known information, necessary formulas. At this point, we're deciding Z or T, and that just comes down to, do you know the population standard deviation? You know it, do a Z. You don't know it, do a T. Then we wrote out our hypotheses. Then we find our test statistic, critical values, so we can compare them. We're going to draw the picture to compare them. Once we've done that, we know, okay, reject, fail, reject, then we need to go back and we need to ask ourselves, what does it mean? Okay, in this is sufficient evidence. We reject sufficient evidence to warrant the rejection of our claim we're trying. In this case, it's not 60. That means we get to accept our null. That in this case, not 60, but it might be greater than or less than if we have a one-tailed test. And then we can look and go, okay, well, what can we tell for this? Well, we can tell from this that people aren't getting approximately 60. They're not on that mark. They are, in this case, less than 60. They're usually coming in before a full minute is up.